And here's your Channel 6.02 news team. Ashley Morse, Julia Morris, Kayla Bell, Bob, Jenny O'Brien, and Caitlin O'Toole. This is Julia Morris.
And Ashley Morse here with the Channel 6.02 news at 10:23, reporting live from Kay's basement.
Today's hot topic is the mole.
The mole is Avogadro's number, the amount of a substance that contains 6.02 times 10 to the 23 representative particles of that substance.
If you have 6.02 times 10 to the 23 representative particles, you have a mole, my friends. And now, in our entertainment section, we'd like to feature the recent X Factor winner, Lana Del Rey, with her new hit single, The Mole Song.
Well, the mole is a number and it's really, really big. 6.02 are 3 sig figs. Multiply that by 10 to the 23, and you've got a number that makes scientists happy. The mole, the mole. The mole helps us to translate between atomic mass units and grams. The mole is a mass whose number is equal to the atomic mass of the molecule. The mole, the mole. Let's take the element carbon, whose atomic mass is 12. 1 mole of carbon equals 12 grams. The mole, the mole. It's the king of all the sciences, and it's really important to know.
And we're back, folks. Isn't she wonderful?
Today's top story is the mole-mass relationship. The molar mass of a substance is the mass in grams of 1 mole of that substance, applicable to all substances, including elements, molecular compounds, and ionic compounds.
You can use the molar mass of an element or compound to convert between the mass of a substance and the moles of a substance. The conversion factor for these calculations is that the molar mass is equal to 1 mole of any given substance.
Here to give us the forecast on mole-mass relationships is Kayla Bell.
Thank you, Ashley. It is a beautiful day here in Moleville. We've got a large front of moles coming in from the west, which will be converting to mass in the afternoon. The conversion factor for these two is the molar mass, which is coming in from the average atomic masses of the elements of the compounds. There's 12 moles of barium chloride coming in from west and converting to grams. If we multiply the number of atoms of each element by their atomic masses and add the product together, we get the molar mass of barium chloride, which is 208.23 grams. This acts as a conversion factor for the moles. If we multiply 12 moles of barium chloride by 208.23 grams over 1 mole of barium chloride, we get 2,498.76 grams of barium chloride. And now, a word from our sponsors.
Come over to the Periodic Brand Table Outlet. This week, we're having a 50% off sale on all items. Save on your end tables, islands, and many more. Come on down!
You gotta love those periodic tables. Now next week, the mass front will be converting back into moles. This is done with the same conversion factor, the molar mass, but simply inverted. When we multiply 2,498.76 grams of barium chloride times 1 mole over 208.23 grams of barium chloride, we get 12 moles of barium chloride, exactly what we started with. And that, ladies and gentlemen, is how it's done. Back to you, Ashley.
Thanks, Kay. And now here's the sports with Bob.
Thanks, Bob. Breaking news. We've just discovered that there's more to this story than we originally thought.
Here with the scoop on mole volume relationships is our field reporters, Jenny and Caitlin.
Hi everyone, this is Jenny O'Brien and Caitlin O'Toole reporting live from the library, here to discuss the mole volume relationship.
Did you know that the volumes of 1 mole of a different solid and liquid substances are not the same? Well, many scientists knew that, but could not explain it until Avogadro proposed his hypothesis in 1811.
Avogadro's hypothesis states that equal volumes of gases the same temperature and pressure contain equal numbers of particles. with the keywords being constant pressure and temperature.
That's right, because the volume of gas varies with a change in temperature and volume. For example, if the temperature increases, the volume of a gas increases. Likewise, when pressure increases, the volume of a gas decreases.
Because these factors would create problems in scientific experiments, scientists discovered a way to fix this. The discovery was known as standard temperature and pressure, commonly referred to as STP in the scientific community. The standard temperature is 0 degrees Celsius, and the standard pressure is 1 atmosphere.
This can be related to molar volume, which is the volume occupied by 1 mole of gas at a standard temperature and pressure.
And don't forget, it doesn't matter if the gas particles are big or small. They occupy the same volume at a constant pressure and temperature. Back to you guys.
I would like to give a big thanks to our field reporters. Thank you, ladies. Well, I want to let you know that now is our time for a joke, our chemistry joke of the day.
You know, Julia, I told a chemistry joke once, but there was no reaction.
This is Julia Morris.
And Ashley Morris signing out.
If you are what you say you are,